This is an example of how to graph a trigonometric function with a phase shift and without plotting each point individually. Let's go ahead and talk about the very common values that we have for this first function, which is a cosine function. So in order to graph it, we need to identify some key elements. The amplitude of this function is the absolute value of 2, which is the number in front of the cosine, which is 2. So that just means that the function is going to be too tall, and the minimum is also going to be at -2 below the x-axis. Then we need to identify the period of this function. The fundamental period is 2 pi, and we have to divide it by the number in front of the x, which is 2. So the period for this function is pi. We're going to have to graph 2 of them. Now, each period for sine and cosine is divided into 4 equal size steps. So pi over 4 is my step size. Now let's go ahead and see what the phase shift is going to do here. So phase shift for this function, first of all, let me rewrite this a little bit to make it a little more clear where the numbers are coming from. 2 cosine 2x, and then that plus sign, I will separate it into a minus and then another minus pi over 2. So this just shows you that the actual shift will go to the left because this value is negative. The value of the shift is negative pi over 2 divided by the number in front of x, so 2. So this is negative pi over 2 times 1/2, which is negative pi over 4, which actually matches our step size, which is a good thing. So what do we do with this? Well, you need to identify the first point, and then after this, just follow the pattern of graphing a cosine function. So for us here, the midline is just the x-axis. We're not moving this function up or down. We do, however, have to move it to the left pi over 4. I'm going to go ahead and label the axis just so we can see it a little more clearly. So on the y-axis, I will need this 2, and I will need this -2 value. On the x-axis, my period is pi. Let's just stick with the labels that are already here. 2 pi. And that means that if the step size is pi over 4, I have 4 squares in a pi, which means that pi over 4 is 1 square on this grid. So let's now look at how this affects the actual graph. So the normal cosine function starts right here, but we don't have a normal cosine function. We have to shift it to the left, pi over 4. Well, pi over 4 is just 1 square, so 1 square left is where we want to start. I'm going to go ahead and remove the other points so it doesn't confuse us. All right, now that you have this starting position, the next step is only 1 square to the right, and the next step should go for cosine function into the x-intercept. So right here should be your next step. Then the next step, again, 1 square to the right should go into a minimum, then back to the x-intercept, back to a maximum, x-intercept, minimum, x-intercept, maximum, and you can graph multiple periods this way. I'm going to go ahead and stop right here. So let me connect the dots. Smooth curves, no edges, no sharp turns. There you go. If you needed to label things on this graph, it is not that difficult because we know that the step size is pi over 4. So this tick mark right here, that's negative pi over 4. Then, of course, you have a 0. Then this one right here is a positive pi over 4. This one right here is pi over 2, and so forth. So doing the labels this way identifies the maximum and minimum pretty easily. Here's the first maximum. Here's the first minimum. It also identifies the x-intercepts very, very quickly. All right, now let's do the exact same thing, but with a sine function. So I will switch my color so it doesn't blend in. And for the sine function, we also have an amplitude, this time the absolute value of 3, so 3. We have a period. 2 pi is the fundamental period for sine, and then you have to divide it by the number in front of the x. So that's 2 pi times 2 over pi. Pi's cancel out, and this is 4. So if the period is 4, then the step is 4 over 4, or just 1. We do have a phase shift here. And that is pi, no negative. This negative sign goes with the x, it does not go with the pi. Pi divided by the number in front of the x. So that's pi times 2 over pi, which is just 2. So this would shift 2 to the right. All right, let's connect it all together. So let's label stuff first. On the y-axis, my amplitude is 3, so I know I'm going to have to go 3 on the top and -3 on the bottom. My x-axis labels have pi's in them. I'm not going to use pi's because my period is 4 without the pi. So I'm going to go ahead and do this. I'm actually going to do this as 4 and this is 8. I need to graph 2 periods. And then that means that this is 2 and this is 1 and this is 3, 5, 6, 7. All right, so for me, step size is 2 squares. And then the shift is 2 of your step sizes. So this would be 4 squares. All right, let's put it all together. Switch color. Let's see. The typical sine function starts at 0, 0. This is the typical starting point. We have to shift it 2 to the right or 4 squares to the right. So this is your starting point for the sine function. I'm going to go ahead and get rid of the other starting point so it doesn't confuse me. And now, when you're graphing a sine, you start right here. And then the next step, which for me is 2 squares, the next step will go into a maximum. Then the next one will go into the x-intercept. Then the next one will go into a minimum, x-intercept, maximum, x-intercept, minimum. I think we're slightly short of 2 periods here, so I may have to continue in the other direction. Minimum, maximum. So actually, we could have kept that original point. But it is better that we erased it and then re-graphed it so that it actually connects the right way. That is the graph of this function.